learners, in the previous session we derived the kinematics equations of uniformly accelerated motion. Now we'll continue our discussion with some common day examples based on uniformly accelerated motion. One of such examples from our daily experience is the motion under free fall. Suppose you drop any object, let's say a ball, from some height. So when you drop a ball, you just release the ball from your hand, then it moves under the influence of gravity alone, and such a motion is termed as free fall motion. In such motion, we just ignore the impact of air resistance. So we ignore the air resistance, and also if the distance traveled by the object is much lesser than the radius of the earth, then the value of acceleration due to gravity is taken to be constant. The acceleration due to gravity is denoted by symbol small g, and its value near the surface of the earth, which is taken as constant, is equal to 9.8 meter per second square. So this is how we are going to consider such examples in this session. One more thing, when we talk about the motion under the free fall, we consider the motion along y direction. So for this, we consider, suppose this is the y-axis, where here I consider origin, suppose, then the upward direction is taken to be positive direction of motion, and the downward direction is representing the negative direction of motion. So all the physical quantities which we use to describe this accelerated motion, this uniformly accelerated motion, we will be considering their values along with the sign conventions. So the physical quantities, like we use initial velocity, which we represent as u, the final velocity, which we represent as v, acceleration due to gravity here, which we represent as a, or we can also represent as g over here, then the height, either when the body is moving against the gravity or is falling towards the gravity or is falling towards the earth, then we can consider the displacement as h. So all these physical quantities are considered along with their sign. How do we allocate the sign to them? Let us see. If the body is dropped in the upward direction, in that case u is taken to be positive. Right? And when a body is dropped initially from some height, then since we are not providing any initial velocity, in that case u is taken to be 0 if the body is dropped from some height. Now if the body is moving towards the earth, then the displacement h is taken to be negative, as according to the sign convention the downward direction is taken negative. In the same manner, if the same object is thrown in the upward direction, in that case h will be taken positive. So this is how we consider the sign conventions. Now let us take one example. Suppose a ball is thrown vertically upwards with a velocity of 20 meter per second from the top of a multi-story building. The height of the point from where the ball is thrown is 25 meters from the ground. So let us consider the situation somewhat like this. Suppose this is a building, a multi-story building, and from this point, let's say we label this point as point A. A ball is being thrown vertically upwards. So the height from where the ball is thrown is 25 meters from the ground. So we can consider that this height of the building is 25 meters. Let me take it as h0. So this is the height of the multi-story building. And the ball is thrown from this point A, which is the top of the building. It is thrown vertically upwards with a velocity of 20 meters per second. Now, so if I talk about the initial velocity from point A, so the initial velocity will be taken as plus 20 meter per second. According to the sign convention, we consider the upward direction to be positive. So that is why u will be plus 20 meter per second. Now, what is the other information? How high will the ball rise? We need to find out how high will the ball rise. So we consider, suppose it reaches to point B. This is the height above the multi-story building above up to which the ball will rise. So we need to find out this much of height. So among the three equations of motion, we can use any one according to our requirement. We have the initial velocity. We know when the ball will reach to the highest point B, its final velocity will be 0. Right? And now to find out the height, which equation of motion we can use? We can use the third equation, that is v square is equal to u square plus 2as. Now, using the sign convention and the values over here, the final velocity is 0. So, 0 square will be equal to, now u square will be 20 ka square. Now, it is 2a, the value of a. How much is the value of a here? That is equal to g, and according to the sign convention, it will be minus 9.8 meter per second square. Now, let's see why the value of a is taken negative. Because whether the ball is moving in the upward direction or the ball is moving in the downward direction, acceleration due to gravity is always acting in the downward direction. So, that is why a will always be negative, or the value of g will always be negative. So, we get it equal to minus of 2 into 9.8. Okay, in this question we can take the value of g to be 10. So, rather than taking 9.8, we can take it to be minus 10 meter per second square. So, it becomes now into, I take it to be h, let's say. We need to find out how high it is going to rise. So, when you solve this equation, you can solve it and you will find the value of h will come to be 20 meters. So, this is the height up till which the ball will rise. From point A reaching to point B, the height covered will be 20 meters. And again, we see that the h has come to be positive. We have not given the sign here. It itself has come to be positive. It indicates that the height which is traveled is in the positive direction. The ball traveled the distance in the positive direction. So, from here we calculated the first part, that the ball will rise to 20 meters. Okay. Now, again, for the second part, let us see how to deal with the second part now. In the second part, we need to find out how long will it be before the ball hits the ground. So, initially we have found here that the height is, this height is 20 meters. This height is 20 meters. So, how long will it be before the ball hits the ground? Means what? We need to find out the time taken the ball to reach from A to B, then from B to, let's say, C, which is just before touching the ground. Just before touching the ground. So, there are two methods of finding out the total time. So, let us discuss the first method. According to this method, we are going to solve this entire motion into the two slots. In the first slot, we are going to discuss the motion from A to B, then from B to C. So, first of all, let us talk about the motion from A to B. So, from A to B, we can simply use the equation V is equal to U plus AT. So, what is the final velocity? When we talk about between these 2 points A to B, the final velocity at point B has come to be 0. The initial velocity is plus 20, and then A key value is minus 10 we have taken, and then T. And now when you solve it, you get the value of T to be equal to 2 seconds. So, this is the time taken by the ball from A to B. Now, let's talk about the motion from B to C. From B to C. So, for B to C, what is the total distance travel? If you look at this situation, the total height travel, the total distance travel is this 20 meters and this 25 meters, right? So, the total height or the total distance travel is 20 plus 25, that is 45 meters. And here we need to put a sign of minus. Why minus? Because if we see the motion from B to C, the ball is moving in the downward direction. So, that is why downward is negative. What is the initial velocity from B to C? It starts from 0, because at point B, the velocity has become 0. So, it is the initial velocity for this motion from B to C. And then what else information we have here? then acceleration will take as minus 10 meter per second square only. So now can I use the equation, the second equation of motion, which says that S is equal to ut plus half at square, wherein at place of S we can substitute minus 45, this is the height or the displacement. U is 0, so U into T will become 0, plus, and it will become minus of minus of 10 into T square. So when you solve this equation, you will get the time as 3 seconds. You can solve this equation and you will get the value of T as 3 seconds. So let me take this time as T1 and this time as T2. This is the time taken by the ball to reach from A to B, and T2 is the time taken by the ball from B to C. So how much is the total time? The total time will be T1 plus T2. So that is how we get total time as T1 plus T2, that will be equal to 2 plus 3, which is equal to 5 seconds. So this is the first method of calculating the total time taken by the ball to reach the ground. Now according to the another method, we can just consider the initial and the final coordinates with reference to the origin. So here again, if we look at this motion of a ball which is thrown from point A, reaches to point B and finally to point C, which is just before touching the ground, then this is the final position and this is the initial position. So here what is the net displacement? The net displacement will be in the downward direction. So that we can say now the displacement S is equal to minus of 25. We are considering the sign convention as well because the net displacement is directed in the downward direction. Now this is the displacement. Now what is the initial velocity? The initial velocity was at point A, which is equal to again plus of 20 meter per second. And the value of A is again minus 10 meter per second square. Now using the second equation of motion, that is S is equal to ut plus half at square. Now let us substitute the values here. At place of S minus 25, at place of U plus 20, T we need to find out, this is unknown, minus half into 10. This is the value of A is minus 10 here into T square. Now, when you solve this equation, you get the value of T to be equal to 5 seconds, which is the same answer which you get with the first method. So, this is how we can calculate the time using these two methods. Now, let us consider one more situation wherein we can also plot the graph for the motion under the free fall. Now suppose the object is released from rest at y is equal to 0. So here I consider, suppose the body or an object is released from this point and this reference point is taken as a region which is equal to 0. And then obviously it is going to fall under the influence of gravity, somewhat like this it is going to fall. Write the equations of motion. So we need to write down the equations of motion for this situation. So the three equations of motion, first of all, we know V is equal to U plus AT. Second equation, S is equal to UT plus half AT square. And the third equation we write as V square is equal to U square plus 2AS. So here, the three equations of motion can be rewritten as, at place of U, we'll write down 0. We know when the body is dropped from some height, then the initial velocity is 0. At place of A, we are going to write down minus of G, which can be taken as minus of 9.8 meter per second square. At place of S, we can write down H. We can use the symbol H for height. So, when we just write down the equations like this, we get the final equations as, substituting the values, we get V is equal to minus of 9.80, substituting the value of G here, or Y is equal to, this is the second equation we get, Y is equal to, again, UT plus half AT square. At place of this, when you substitute, you get Y is equal to minus of 4.9 T square The first equation is V is equal to minus of 9.8t, and the third equation becomes V square is equal to minus of 19.61. So along with the units, it can be meter per second. This can be in meters, because this is the equation for the displacement, and V square has to be meter square per second square. It is velocity ka square, right? Now, these are the three equations of motion for a object under a free fall. Now, how to plot the velocity time graph, the displacement time graph, and the acceleration time graph. So we know, first of all, starting with the acceleration time graph, the value of A is minus 10 throughout the motion. The value of A is uniform throughout the motion. So it is a straight line parallel to time axis towards a negative direction, right? So this is a graph you will obtain when you will plot acceleration time graph. Now, we know that looking at this equation, we can see that V is directly proportional to T. Looking at the first equation, we can conclude that V is directly proportional to T, so that we should obtain a straight line graph for velocity time which is inclined to time axis. So substituting the values also, we can just plot the graph as you can see here. Again, for displacement time graph, you see here displacement y is directly proportional to t square. So we get a curve like this. Again, for a free fall, if this is the origin, at the highest point is the origin, then the displacement will be towards a negative direction. So that is how you get a curve. We don't get a straight line, we get a curve since y is proportional to t square. So this is how we can plot the three graphs, the displacement time, the velocity time, and the acceleration time graph for a freely falling object. Now let us talk about Galileo law of odd numbers. So let us talk about its statement first. It states that the distances traversed during the equal intervals of time by a body falling from rest stand to one another in the same ratio as the odd number beginning with unity. For example, you can say it is 1:3:5:7 and so on. Now let us try to understand what does this law mean. So for this, again I consider a situation. Let's say a body is falling freely from this height. So initially I consider here that after a time of small t, suppose here time small t is equal to capital T, then after the another equal time interval of, let's say, when time becomes 2t, then I consider when time becomes, let's say, 3t. So this is an equal time interval which I have distributed here, and we know that in equal interval of time the distance travels goes on increasing. So as the object is fall from here, in the first time interval the distance traveled will be least, then in the second successive time interval the distance increases and the process continues when it is a case of free fall motion. So now suppose here I consider it to be, let's say, S1, here I consider the distance traveled to be S2, here I consider the distance traveled to be S2. So for S1, using the formula ut plus half at square. So if I just talk about the magnitude of A here, A is equal to G, or yes, we can just write on the symbol G here, and U is equal to 0. Here the initial velocity is 0 since the body is being dropped freely from this height. So we get S1 is equal to, this term becomes 0, and we will get it equal to half G T square, keeping the value of small t to be capital T, which we assumed here. Now, what is the distance travel S2? S2 means the total distance travel in the total time 2t. So it will be again ut plus half at square, the same formula we are using here, and then we get S2 is equal to, it will be now half G, at place of small t we need to substitute 2t. So it will be 2t square, right? So which can be written as half gt square multiplied by 4. So S1 is half gt square, S2 is half gt square into 4. So can I say it is 4 times of S1? Similarly, the total distance traveled S3 in total time 3t. So again using the same formula we will get S3 to be equal to, it will become half g into 3t square, or finally we will get half gt square into 9. So these are the distances travelled in time t1, in time t, 2t and 3t. So what we are going to find out now? We are going to find out the distance travelled in equal intervals of time. So let us talk about the first interval of time which is equal, that is from t, this is one equal interval of time we can say. So here between, if we need to find out what is the distance travelled, the initial distance travelled between 0 to t second is, we know it is half gt square. Now between, if I need to find out this distance, what is the distance travelled when time is t and when time is 2t. So for this what I will do, we will subtract S1 from S2 and that will be equal to, yes, S2 minus S1 will give us 3 times of half gt square. Right? So if I consider this distance to be x, then this distance can be taken as 3x. Right? Because it is 3 times of the distance travelled by in S1. Similarly, if I need to find out how much is the distance travelled in this successive time interval, so we need to find out S3 minus S2, the total distance travelled in 3t minus the total distance travelled in 2t time. So when you subtract S3 minus S2, what we are going to get? That is 9 minus 4 will get 5 times of half gt square, which can be written as, this will be capital T, sorry, this will be half gt square, or we can write down it as 5 times of x. Now let's focus here. Just look at this. For S1 it is x. For S1 it is x. So I can again write down here, let's say the distance travelled in S1 in the first time interval is x. In the second time interval, I call it as delta S1, then I call it as delta S2, that is in the second. I can say it as nth second, that is a second. That will be equal to 3x. Then in the third successive interval, it will be 5x. So now, if we compare it as delta S1 ratio delta S2 ratio delta S3, it will be equal to x, it will be 1:3:5 and so on. So this is what the Galileo law of odd number says. So this was a law which was given by Galileo Galilei, and he was the first one who actually gave the quantitative idea of free fall motion. Now let us talk about the stopping distance of the vehicles. So as the title itself suggests, that stopping distance means if when you apply brakes to the vehicle, it doesn't stop suddenly, right? Even we have observed on the traffic signals also, when we see the red signal, if the red signal is visible over there, then we just apply the brake to a vehicle, but it do not stop instantaneously over there, right? It takes some time, it travels some distance. So the distance traveled with the vehicle when the brakes are applied until the velocity becomes 0 is called the stopping distance for the vehicle. Now let us talk about the stopping distance of the vehicles. As the name suggests, stopping distance means what? Suppose I consider a vehicle is moving with some velocity, maybe uniform or accelerated, whatever, and as it approaches to some traffic signal and suddenly it becomes red, then the driver applies the brakes, and then what we observe, the moment the driver applies the brakes, the vehicle do not stop suddenly. It takes some time. It travels some distance. So the distance which is traveled by the vehicle, right? So the distance traveled by the vehicle before it comes to rest is called the stopping distance of the vehicle. And let us denote the distance by d with the suffix xs here. And when the vehicle stops, that time the velocity can be taken as the final velocity, which is 0. Now let us derive the expression for the stopping distance of a vehicle in terms of the initial velocity and the acceleration. Now again I consider the same situation. A vehicle which is traveling, which is moving with some velocity u at a particular instant, and at this moment the driver applied the brakes. So the acceleration can be taken as minus of u. The acceleration will be minus of a, because this is a case of deceleration. The speed has to decrease. So the final velocity will become 0 when suppose the vehicle stops here, so that the velocity becomes 0. So we can say v equal to 0. Initial velocity as u, acceleration as minus of a, and the stopping distance as d with the suffix s. Now using the third equation of motion, that is v square equals to u square plus 2as, we know that finally the vehicle has stopped, so v is equal to 0 equals to u square. Now acceleration is minus because it is a deceleration, so minus 2a, at place of s I write down d suffix s, that is a stopping distance. And when you solve it, solving we get 2a ds is equal to u square, or the stopping distance ds is equal to u square by 2a. So this gives us the expression for the stopping distance in terms of initial velocity and acceleration. So now let us see what we have learnt in this. Let's find out what will be the effect on the stopping distance ds, which is actually equal to u square upon 2a of a vehicle if its initial velocity is doubled for the same deceleration. So can we apply the same equation to solve it? Yes. Here for the same acceleration we see that ds is directly proportional to u square, that is for same acceleration. For same value of acceleration, ds is directly proportional to u square. Then from here we can conclude that since ds is proportional to u square, so when the initial velocity is doubled, then the stopping distance will become 4 times. 2 times of u, right? So the stopping distance will become 4 times of the initial stopping distance. So this is how we calculate the stopping distance. Now let us see what we have learned in this session. An object in free fall experiences constant acceleration if air resistance is ignored or negligible. Next, on earth all free falling objects have an acceleration due to gravity which averages 9.8 meter per second square. For objects in free fall, upward direction is normally taken as positive for displacement, velocity and acceleration. When the brakes are applied to a moving vehicle, the distance is travelled before stopping is called the stopping distance. The reaction time is a time a person takes to observe, think and act.